Mr. Chairman, David, thank you very much, ladies and gentlemen. So, my name's Tony Carruthers. I'm the Commercial Director for Cuadrilla Resources. My theme today is the future of shale and the challenges in delivering it. Now, this is a very big topic, so here's what I'm going to do in just 15 minutes. I'll tell you a little bit about what we're doing in the UK, Cuadrilla, but I'm also going to tell you a little bit about what we believe. Now, clearly the answer to the first part of the title lies in how we address the second part. The future of shale will actually depend on how we address the challenges. Now, just a little bit about ourselves first. We are a UK company. We have a number of licenses in the UK. We also have a number of licenses in Europe, in Poland, Holland and Hungary. But this license here, you can see, is our Poland license. It's Pedal 165, and it's actually the largest license in the UK. It's 1,200 square kilometres. And the area that's highlighted, you can see that just there, happens to be the area of the 3D seismic we shot just earlier this year, and so the whole license is shown in the square there. Now, I can't talk just yet about recoverable volumes of gas in this license, but we're confident that the gas in place is at least 200 TCF, and I'll come back to that later. That's a lot of gas. Of course, there are two aspects to shale gas developments in the UK, and the first one is the usual technical aspect, but the second one is the socio-political aspects. So let me talk about some of these challenges. Now, if you like, there are two journeys of exploration here. Normally, when we prove up a new hydrocarbon resource, we prove that the oil and gas is present, we prove that it's technically recoverable, and that it's of a predictable quality and a predictable quantity. Now here, perhaps the larger risk to address is not whether the gas is there in enough quantities or whether it can flow, but whether we'll be able to develop it. So to do this, we need to prove that the shale gas from our Poland license here, for example, can be developed safely, that it can be developed in an environmentally responsible manner, and in a responsible manner that's also acceptable to the community. So, interestingly, after a long time in the industry, it's really this second piece here that's the critical determinant. So we'll talk a little bit more about that. Now, this picture is taken from the opening ceremony of the Olympics, which was a fabulous spectacle, but it also tells a fascinating story. Britain, I believe, has a certain ambivalence about industry now. Industry has brought great technological and economic progress, but we're all very aware of the cost. Nowadays, the industrial revolution has given way to industrial evolution. Now, people in the UK are much more conscious of the environment, and quite rightly so. So, interestingly, these images of the Industrial Revolution and the journey that Britain went, this started off in Lancashire, the dark Satanic Mills. Now, clearly, we don't want to recreate that, but this is the sort of thing that people are worried about. And I believe that this ambivalence is behind some of the reactions we've had to shale gas. So what I'm saying here then is that the social implications are key. Now, I was speaking about this a couple of weeks ago at a conference in Birmingham, and I held up two pieces of rock. Now, I don't have those pieces of rock, but let's do a thought experiment. One piece of rock is a piece of tight sandstone. It's a like sandy grey colour. And this piece of rock is a piece of shale rock, and it's the same size. It feels the same, but it's grey in colour. Now, this rock is a good rock, but this rock somehow is a bad rock. Now, these rocks, we've been fracking for decades in the UK. We are still fracking tight gas sands in the North Sea. We've been doing fracking for decades. The technology we use to frack these rocks is precisely the same. We use exactly the same well technology. We use the same well integrity measures. So in all regards, it's exactly the same, except, and in fact, in the methane in the shale is exactly the same. So what's different about it? Now, I trained as an engineer and a scientist, and sometimes I'm baffled by the stream of misinformation and negative propaganda that's hurled about shale gas. But we do need to listen to people's concerns, and we need to hear their concerns. Now, so at Cuadrilla, we've come to realise that we would like a dialogue. What we want is a thoughtful debate. We want a thoughtful debate. Now, recently, there's been a number of quite thoughtful reports that have come out. There's one here which was produced in June by the Royal Society and the Royal Academy of Engineering. And they've concluded that the health, safety, environmental risks associated with hydraulic fracturing to extract shale gas can be managed effectively as long as operational best practices are implemented excuse me, and supported by regulation. We fully support this report, and we fully support the recommendations. We talk about the recommendations point by point and how we're committed to them in practice, and in fact we're bringing out a document shortly that will explain to people exactly how these recommendations are being implemented in practice. So, for example, in Cuadrilla, we have the usual systems and process in place. We have clear policies about safety, health and safety, and the environment. Underneath that, supporting that, we have a risk management framework. And finally, all of that is underpinned by what we do in the workplace, how we behave, what we do, what's permitted and what's not. So, these are very deeply embedded in what we do. And here's just a couple of examples. Now, we are committed to, but we're also very capable of operating in a safe and environmentally responsible way. And I'll just address some of the points here that are of interest to people. So first of all, groundwater protection. Now, I'll come back to that in a slide in just a moment. But in fact, partly because all of our wells are drilled to exactly the same high UK standards as any other oil and gas well, but partly also because of the physics of shale extraction and the depths involved, there is essentially no risk to UK groundwater, but we can demonstrate that. We talk a lot about hydraulic fracturing, the chemical usage. In fact, in Lancashire we use water that's just drinking water. We are supplied it, a 12-inch main from United Utilities, who supply drinking water in Lancashire, and we obviously use sand. There are very tiny traces of other chemicals. The most, in fact, there's one other chemical which is exactly the same as it's a friction reducer that you also find in shampoo. Seismicity is another really big topic. When we hope that we'll start resuming fracturing operations soon, and we have an incredibly detailed seismic monitoring array system. So this piece of Lancashire is the most seismically monitored piece of real estate in the world, including the San Andreas Fault. If anything moves, we'll know about it, and we have a very clear set of protocols in place that we've agreed with DEC that we can follow to make sure that we're monitoring every event as it happens. The same with waste disposal. We adhere very strictly to the existing guidelines. The same with land use, and of course safety. Just something on the groundwater. This is a schematic of a well. It's got 3 strings of casing. For those of you not in the oil industry, that's basically we have 3 pieces of steel pipe and 3 sets of cement between the shallower formations and the inside of the well bore. This leads to complete isolation of the aquifer, and again, this is completely standard UK procedure. There's absolutely no possibility of fractures growing. The Boulder Shale down here in Lancashire is about 8,000 feet, 10,000 feet deep. There's a very interesting study done by the University of Durham recently, and they went to have a look at fracture growths around the world, including natural fractures as well as artificially induced fractures. The largest fracture in the world that's ever been is about 550 metres. It's actually just practically not possible. We also have this thing called a Manchester Marl, which is an elastic formation some thousands of feet above the shale that would also act to stop any fracture. So there is no risk of this aquifer. This aquifer also actually is a very, very saline aquifer. It's not used for drinking water. But nevertheless, we take the strictest possible procedures to protect it. Now, engaging with the community. Over 300 folks locally have been to our sites since February last year. We have a dedicated free phone, community information line, email address and website. Most interestingly though, we have Q&A sessions, and we typically will take a village hall locally in one of the villages in Lancashire, and we invite people just to come along and talk to us, and we're there typically for 5 or 6 hours. We provide tea and biscuits, and pensioners come along, young mothers with children, young folk, all sorts of people come along, and they come along bristling with questions because they've heard all sorts of things. But I know from my own personal experience that after talking with folks, just explaining what we do and what we don't do, talking about the facts in a rational way, they usually go away pretty comfortable, actually, in fact very happy. So they come in talking about seismicity, and they talk about aquifer pollution, but probably the sort of things that they should be thinking about is, well, okay, you know, what's the visual impact of a drilling rig? What would the impact of a shale development in Lancashire do for traffic on the roads? Well, these are good questions, and that is exactly the sort of dialogue we would like to have, a rational, facts-based dialogue. Now, when I was a young engineer, I actually worked in the East Midlands oil and gas fields. Now, they've been there since the 1930s and 1940s, as I'm sure some of you know. Now, these onshore operations have coexisted quite comfortably with the local population, integrated in part with sometimes with the coal mining communities, but existed comfortably and safely with the local communities for years and years. And in many cases, people driving through the area would never even know that this is going on. And I really believe that the same would be the case for a development in Lancashire. This is an interesting photograph here. This is an artist's impression of what a potential shale gas pad development site would look like. It has 8 or 10 wells on it. It's bermed. And once the rig has gone, this is the sort of profile that you would see. Behind the hedge, it's essentially invisible from more than 50 metres, 100 metres away. Now, opponents of shale gas would like to say that we'll despoil the countryside. It's just not true. The rig might be there for a period, but our rig is an electric top drive rig. It's one of the latest rigs built by Deutag, and it's silent from more than 50 metres away, 100 metres away. You can't hear it. And it's an interesting comparison to think about if you compare that to having a wind turbine in the same location, which of course is very large, it's very loud, and you have that for life. Now, the reality actually is that there'll be a multi-well pad development in the event that this is developed. Now, each of these well pads would be several kilometres apart, and you can see this is just a piece of countryside. It's not in Lancashire, but we've drawn in to scale a pad there, another one there, and another one there. So that sort of gives you an idea about what a very small footprint this would have on the landscape. Now, the trick to this, of course, is horizontal drilling. So from one of these pads, we go down thousands of feet, and then we go thousands of feet out laterally, which means that we can develop quite a lot of shale gas resource from a very small surface footprint. And the other interesting thing about Lancashire shale compared to a lot of the shale in North America is how thick it is. So in North America, typically the shales are hundreds of feet thick. In Lancashire, they're thousands of feet thick. So in our licence, the Boland Shale is thousands of feet thick. So that actually gives us tremendous advantage, because that means that with one well location, you can drill a lateral, and then you can drill another lateral, and then another one. In fact, in some parts, you could envisage 6, 7, sometimes 8 or more laterals in the same vertical sequence. So that means you don't have to keep going chasing real estate. You don't have to have rigs every few hundred yards. What you actually need is just a small pad that you can develop carefully using laterals, and then another one would be quite a long distance away. So one of the interesting consequences of that is that you end up with much larger recovery per pad. So economically, it's pretty attractive. So perhaps, depending on the number of wells you drill, the number of laterals you drill, maybe even a quarter to a half a TCF per pad. So, now, there's been a lot of discussion about what exactly are the recoverable volumes that we would have in our Lancashire licence. Now, for the first time in my career in the oil and gas industry, over 30 years, the answer to that question of recoverable volumes is not a function of the gas in place. There is so much gas here, it's a function of what's recoverable gas per lateral constructed, and therefore of how many of those laterals go in. It's not a function of gas in place, it's a function of how many of these laterals. It's not even a function of number of wells, it's a function of number of these laterals. So, as I've said, Lancashire Shale is very different from much of the North American plays because it's thousands of feet thick. And so that gives us this scope to drill these multi-stacked laterals under a pad. But my point today is the real factor is, do we want to do this? Will the people in whose backyard where this is happening be accepting of this? We hope so. As a nation, do we want to take advantage of this resource miracle? Now, onto the potential impact on UK CS gas supply. I have a chart here which is a future projection of UK gas consumption and its sources. Now this is from Poiri, so my thanks to Poiri. I don't know if they're here today, but hello. And what we've done here is plotted one of our Lancashire Shale scenarios on that. Now clearly there is a large amount of uncertainty around this, and I fully support Chris Barton this morning. You hear a lot of facts or assertions in the media. About, we had one the other day in the FT and ECC. Now I know the folks at ECC very well, the energy contract company, but where did they get their numbers from? Who knows? The answer is how many of these laterals we want to drill. So we've taken a reasonable scenario here, and we've created a wedge of gas that could be envisaged from our Lancashire licence, and it has a very gradual build-up, and that build-up is a function of obviously the number of rigs you have and the number of laterals you drill. But in this you can see that it has the potential to make a very significant contribution to the UK's supply. It could potentially supply more than 20% of UK's consumption, and that is the equivalent of about 40% of UK's imported gas. Regeneris did a study recently, and they were estimating 5,600 jobs created, 1,700 of which would be in Lancashire. There may well be more than that. Now, the effect that shale gas would have, this is again quite a big question, but clearly on the margin it will displace imported gas. It's mostly LNG, but some of it is Norwegian gas, and this is quite a subtle function of the pricing in the model. So we believe this does have a material impact, and most interestingly of all, we believe that shale gas in the UK will actually reduce the UK's carbon footprint, and that's because it would displace coal in electricity generation. We are, in this current environment, importing more coal from the US because it's cheap and we're burning it. But it will also displace more CO2 or methane intense transport of long distance gas. If you're piping gas from Alaska, from the Arctic in Russia, for example, or bring it on a tanker from thousands of kilometres away, there will be a significant carbon implication. So My friend Graham will be talking a lot more detail about some of the scenarios for shale. This is the same chart. It's the same numbers, but it's just showing the domestic production. The key issue here really is about timing. I probably would move this out 1 year. We put this chart together a few months ago, but it really depends on politics. We would like to get started, and if we're allowed to resume operations, we believe we could have the first pad up and running perhaps in 2015. So, in summary then, there is a lot of gas in place, certainly in Lancashire. But we do need to validate potential flow rates, and in order to do that, we need to frack and we need to test, and then we can have some facts in this discussion. We read in the papers all the time how much gas there is and isn't in Lancashire, and how much of it is and isn't recoverable. Well, we need to find out. But we do know that it can be developed safely and sensibly with society. We do know it has the potential to significantly reduce import dependency. Now, clearly, as Chris Barton is saying, the answer is to have multiplicity in your portfolio. That seems to be a sensible thing for me. We do believe it has the potential to moderate carbon impact on the margin. And we certainly believe it has the potential to create jobs and contribute significant tax revenue. So we believe this is a national treasure, an amazing resource for the UK. We believe we can develop shale gas safely and in an environmentally and socially acceptable way. Natural gas is the perfect companion fuel, as we saw earlier today, as we move to this lower carbon future. But we do need companion fuels. We do need gas to do that. So the reality is that the UK will be needing gas for a long while yet. UK shale gas will displace coal we're currently burning. So I would ask folks in the UK, would you buy more gas, say from Russia or Statoil, with all due respect to my esteemed colleagues here, or would you create thousands of UK jobs? Would you rely on external imports or provide a huge contribution to the UK's security of supply? Would you buy more gas from the Gulf or provide billions of tax revenues to the UK? But, ladies and gentlemen, you can't just throw a switch to turn on UK shale as an option. It takes time to build the skills, get the planning done, attract the investment, and we've invested a lot of money. This is not public money. To build the infrastructure. So in order to do all those things, we need to start. So, the answer, ladies and gentlemen, to the future of UK shale gas is not about how much is there, but it's about how much do we want it. Ladies and gentlemen, thank you very much.